Here we've got a question involving Hess's law, and I've been asked to work out an equation for the decomposition of potassium chlorate 7, and once I've got that equation I have to work out the enthalpy change for the reaction. Now what we've been given here is we've been given enthalpy formation data. So remember, if we've been given enthalpy formation data, we have to follow up the following Hess cycle. So my reactants to products, and then here we've got the elements. And this time the arrows will point upwards. So if this is enthalpy change 1, enthalpy change 2, enthalpy change 3, if I want to work out enthalpy change 1, if we look at the direction of the arrow, the number 2 arrow is going the wrong way, 3 is going the right way. So this time enthalpy change 1 is 3 minus 2. We could say then that the enthalpy change 1 is equal to the sum of the enthalpy of formation of the products minus the sum of the enthalpy of formation of the reactants. So that's the Hess cycle we set up if we're given this enthalpy of formation data. So let's have a look at this specific example. We need to look at the decomposition of KClO4. Decomposition means it's not reacting with anything, it's just going to break down to form products, and it tells us in the question it produces potassium chloride and oxygen. So we form KCl and 2O2, and that there is my reaction, and that's the enthalpy change that I want to work out. Now because we've been given enthalpies of formation, then we write down the elements that the reactants and products are made from, and that is K plus a half Cl2 plus 2O2. Remember, the arrows are now going to point up. So what we've got then is the enthalpy formation of potassium chlorate 7 is minus 434. And the enthalpy of formation of potassium chloride is minus 436. Now you've got to remember, obviously, the enthalpy of formation of an element here is 0 by definition. So we completely ignore the enthalpy of formation of O2 because it is 0. So based on what we've said here on the left, the enthalpy formation data tells us that we need to go, for this enthalpy change here, it's 3 minus 2, and this is 3 minus 2, so this gives us minus 436 minus 434, and that gives us an enthalpy change of minus 2 kilojoules per mole. And that there is my answer. So again, the key takeaway is if I'm given enthalpy formation data, we need to set up a Hess cycle like this or use this equation here.